Welcome to my channel. This is Shakil Ahmed. In this tutorial, we will learn about modeling time to event data in R. First, we discussed about categorical data analysis, and then we analyzed continuous variables, and then we analyzed count variables. Now we are discussing time to event variable. Time to event variable is basically used in survival analysis where we have a time to until certain events occurred. For example, time to death, time to recovery, time to certain disability, time to different chronic conditions. These are all the time to event data. And in medical studies, especially in clinical trials, we are interested in the survival of patients for certain time period. When we are applying different interventions, then we want to measure the time to survival from certain time period to uh, their survival until the event occur. For example, we recruit cancer patients, and for example, we just do chemotherapy, and then we see their survival for a longer period, mostly 2 to 3 months or more longer survival. But cancer is more has a low survival ratio than other diseases like diabetes. We have a longer period of survival. So we need to estimate the probability of survival or the hazard rate. Hazard rate is basically the probability of uh, dying, the instantaneous probability of dying during a period if a patient is survived until a time point t. So we will discuss the application of survival analysis in R when we have time to event data. So we start with uh, the packages, the library survival. You can see, and you can, if you want to see the detail of the survival package, you can just click on help is equal to survival. You will see all the documentations and availability of different data sets in this package. And then we need to uh, use ggplot2 for survival curve that is used to visualize how the survival is, how the patients are surviving for a time period, for the follow-up time. And GG45 is also used to make more attractive survival curves. And we can have data on survival time and status. Status means whether the patient is died or censored. Censored means if we are stopping the study, then we don't know we can't observe their death after that time point. Even before that time point, they may die due to some other reason, or they may drop out from the study. That also we categorize in the censoring group. Although we have competing is risk models where we take the deaths due to other reasons instead of the risk of interest, in which we are basically, for example, like a cancer patient uh, maybe uh, dies due to accident or some other disease, then we can't say that uh, he or she is not survived. So in that case, those type of risk or the events are we can say the competing in event of interest. So Uh, we just starting from the basic. We have survival time and we have death status, whether died or not, and we can write SRV as the survival time in terms of this. For example, we have then we are just have a plus with the censored observations and uh, empty no plus with uh, observations with outcome of interest. So you can just write the survival data in terms of SRV command. And we need to serve minor command to obtain a data set from of lung cancer. And you can just see the data where we have instances and time and status and age and sex and other eco- ecological variables, biomarkers. We have a lot of variables, but we are just interested in the time to death and the status of death, whether the patient is died or survived. Here, one refers to, I think, death, and two refers to survive. You can see the documentation of lung cancer for details about this data set. So you can see we can just fit a Kaplan Meier survival curve. Basically, Kaplan Meier survival curve is a non-parametric approach which is just used to estimate survival curve for different time period. And the survival function basically we are estimating. So the data is long and we have survival data with time and status, and we are including no grouping that why that's why we are basically making for overall data set. If you are uh, making groups or categorizing the data, you if you want to compare by groups, then you need to add the grouping variable or variables here. So we just see this is the just call of uh, fit not a survival curve for overall data. That is, we have total number of observations and how many events occurred. 165 events occurred in 228 observations, and the median survival time is 310. And these are the confidence interval for the median survival time. So this is just a simple summary of the Kaplan Meier model, and you can find this full summary of the overall model using summary fit not, as we named as it as fit not. So here you can see the detail. The, for different time points, we have number of people at risk and number of events and survival, standard error, and the confidence intervals. Basically, what we need is these data set, these information for while conducting Kaplan Meier. So these are the survival estimates basically. At fifth month, for example, if the data is in month or is in days, then for, on fifth day we have 99.5% patients are alive, and if we see on 286 day we have only 50%, 54% of the patients are alive. So we can just interpret in this form, and these are the number of deaths on these time points. So you can now we can just see the survival in male and female, how the survival differs in by gender. So you can just see and then see the summary. We have survival for sex is equal to 2 for females, I think, and this is for males, sex is equal to 1. So you can see different survival in different. groups, and we can compare. This is just numerical comparison, and we can just see visualize how the survival is higher in one group as compared to the other group, and we can sort in terms of table. We can just write a summary where the total number of records, that is the number of maximum number of and start. These are basically and total number of observations and the number of events, and this is uh, mean survival time, and this is standard error of mean, and this is median, and this is these are the confidence intervals. So this is the summary of the fit note, and you can see the summary for fit one. That is, we have for uh, both male and female. For males, we have 138 male, and events are one higher in males as compared to females, and we have average number of events in male and female, and the median and the standard error of mean. So these are we can just compare the median survival time is higher in females as compared to males, and with these confidence intervals. And now we can just visualize. We write. We can report the data in more appropriate form, where we need the time and the uh, by time we just write the number at risk, and we write the number of event, and we write the how many are censored, and we write the proportion of survivor and their confidence interval. So this is the most appropriate way of reporting your data for survival analysis. You can just see. So this table you can uh, copy in your publications. So we are interested in number of survival, and these are the time points, and we are just taking the first 10 time points data on first 10 time points, although it's a long table. But it's up to you if you want to just summarize, just report the number of total observation, number of events, and number of mean survival time, median survival time, and their confidence interval. That's okay. And the other way is to display with uh, survival curve. So we have fitted the fit one, that is for male and female, and we are also just showing the p-values and confidence intervals, and the risk table. Basically, it will give a risk table below the figure, and risk table with colors by strata. Basically, for male and female, we will give different colors, and line type will differ by strata, and survival median line, that specify the where is the median is located. If you give this option, just it will give a line from horizontal axis to the survival curve. And what should be the theme? If you want to change the theme, you can just change. And these are the colors codes, and you can change accordingly if you want to change. Now you can see the survival curve. So this is a survival curve. we have p-value, we have time and survival probability, and this is for sex one for male and this is for female, for example, and these the colors showing the confidence intervals for the two survival. So we can see the median survival time is higher for female as compared to for male. These are the median survival time, and overall we can say that the survival is lower in male as compared to females, and females are more have a higher hazard than uh, lower hazard than males. Basically, hazard is the we can just see if there is a higher hazard then and there is a lower chance of survival probability, uh, low chance of survival, and you can appropriate fit more appropriate plot including other things like you want to include confidence interval style by step as this is just highlighted, and you can write the time in days, and you are again changing the theme with light, and you are using absolute number and percentage both in the risk table. This is the risk table. Here just only the number of people at risk are mentioned, but you can use both the percentage and the numbers. And then risk table white text column is equal to true. That means it will give a color risk table for text annotations, uh, just like these different colors. And censoring plot is equal to true. That will give the number of censored observations, and survival median line. It will also, as we already discussed, so we can just plot this. This will be more attractive than this one. Now we can see a lot of things here. So here is time points, time in days. Here is also time in days, and we have survival curve for male and for female, and these are the confidence intervals for survival curve for male, survival curve for female, and we have overall p-value. There is a difference between survival of male and female, which rejects the null hypothesis that the survival is equal in both gender. So this is a compact table. You can see the number of people at risk on different time points and their percentages as well. And you can have plot of the censored observation on different time points. So if you want to make more details, you can just want to put more details on your curve, you can just uh, do such type of plotting. And the last thing is you can again see this is for fit one. We can see the quantile values, different quantile values. So these are the quantiles for sex by sex, and these are the lower quantiles, lower limit, and these are the upper limits. So this is the basic just Kaplan Meier approach where we are estimating survival for different time points, and we can compare by groups, for example, male to female. But when we have more than two groups, then it is difficult. Although we can do the we can just plot for different groups like this. And but when we have different predictors and we want to check their effect on the survival, then we need to go for Cox regression. So next video uh, we will try to discuss the Cox regression model. And thank you for watching. And don't forget to subscribe the channel.